Hey everyone, happy Tuesday. Hopefully the practice went well yesterday and I missed kind of our live sessions, but happy Tuesday. Tomorrow's Wednesday, a work day. You're making it through. Very, very good job. I want to back up a second and make sure that we still remember some things that we learned a while ago, right? It's so easy to just kind of forget everything. So we're going to kind of review our absolute value and then we'll move on, okay? So if we're asked to graph the absolute value, I want you to pause your video and jot down on the side and try and graph this. So I suggest you first trying to find the vertex, put that in there, and then graph. So pause your video right now and do it. Okay, so now let's see what you came up with, all right? So the vertex, remember, is this number, switch the sign, and then it's this number. That's all you gotta do. So I'm gonna scroll down and I'm gonna say, okay, 2, -2 is right here. Now before I just draw my V, I need to remember that there's a negative outside here. So it's going to point in the opposite direction. There's my graph. It also asked about the domain and range. Domain and range. If you remember from last week, or a few days ago, right? Domain is all of the X values, and it's always going to be all real numbers for absolute value. The range are the Y values. So this time, Y has to be what? If we need these values to be included, we want everything less than -2. And it can be equal to -2, so I'm going to write it like this. So we've got our vertex and our domain and range. Great job. Okay. All right, that was to get our brains moving. So today we are switching into section 1.5 in your book, if you're following along. And this is all on radicals. We just had a big section on exponents and raising things to different powers, right? Well, now what if we want to undo those powers? What we need is a radical. Yeah, math truly is radical, isn't it? The most common one that you've heard is the square root, right? And the square root looks like this. It does not look like literal square roots. But the square root of 4 is 2, right? We'll talk about what that means in a second. And by the end of today, we should be able to solve or simplify expressions just like these, all right? So what we're truly doing is just simplifying radicals. Okay, so let's back up a second. When we're talking about squares and square roots, I want to imagine, right? If I take a square like this, and the dimensions are 4 units by 4 units. If I counted up all of these boxes, I would have 16 in total. So 4 times 4 is 16. And the square root, meaning if I take that perfect square and I find one dimension, it's 4. All right, so many of you already know what these square roots are, but I want to go over them just to make sure we're clear. Okay, and I thought I chose a different color, but you know what? I'm going to start with 1. 1 squared, 1 times 1, so that's really what I'm doing is 1 times 1. That's just going to give me 1. So I'm going to kind of ignore this one. Okay, now let's jump down. Let's do 2. 2 squared is 2 times 2, and that's going to give me 4. 3 squared, 3 times 3, that gives me 9. I'm going to make a big long list here. 4 squared, well, we just did that one. 4 times 4, right? That's 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. I'm going to go all the way to 10, so hang tight. 8 squared, 8 times 8 is 64. 9 squared, which is 9 times 9, 81. And my last one is 100. Okay. You should become very familiar with this list. When I say a perfect square, I mean the ones in this column here. Okay, and I'll extend my line. Those are your perfect squares. Okay, so you should be very comfortable with those numbers to say, oh, 4, that's a perfect square. 25, that's a perfect square. 36, that's a perfect square. So I almost suggest you memorize, if you don't already know these, memorize this list, okay? So that we become very comfortable with them. Because we're going to need to know these perfect squares to simplify square roots. Okay, so if you don't already have these, I suggest you pause your video, and I'm going to do it in sections. So pause right now and write these down. And pause right now and write those down. Okay. All right, so how do we simplify square roots using this? Well, we want to find the biggest perfect square that we can factor out. So what does that mean? So let's look at this 45, right? Now, I'm going to keep the radical. That's what this symbol is called. It's called a radical. I'm going to look at 45 and I'm going to say, okay, if I inside the radical, 45 can be written in a number of ways. I can say it's 1 times 45. 2 doesn't work. 3 does work. It would be 3 times, now Miss L's brain is not working. 15, I knew that. 4 doesn't work. 5 times 9, that sure works. And that's it. So now I want to look at my list of factors. Which one of those has a perfect square in it? So now you have to look back at your list and you're like, okay, well, 4 is a perfect square, but 4 is not in my list. Okay, 9 is a perfect square. Is 9 in my list? Yep, it sure is. Is 15 in my list? Nope. Is 45 in my list? Nope. So because of this 9 here, I'm going to use that. And I'm going to say 45 is the same as saying 9 times 5. I didn't need such a big radical here. Now I'm going to take this bit by bit. I'm going to say, okay, what this is really saying is I can say the square root of 9 times the square root of 5. I can split it up. Okay. Well, the square root of 9, if we go back to our list and we work backwards, the square root of 9 is 3. So I'm going to go in here and I'm going to say, okay, well, the square root of 9 is 3. The square root of 5 doesn't exist. So I now have simplified and I'm done. Okay, so the key again is finding the biggest perfect square that you can factor out. We're going to do a bunch of these, so if you're not with it yet, don't worry. Well, I want to show you kind of how this works, and I'm going to show you how this works with a variable, because we can still simplify radicals using variables. If I have the square root of x to the 3rd power, x cubed, what this is really saying is that I am taking x times x times x. Well, there's a grouping of 2 here. So I can pull out an x and I'm left with the square root of x. Think about this. When I say that, the square root of 16, when I say that that is 4, it's because 16 is 4 times 4. So there's a grouping of 4s. So I can pull out a 4. So there's a grouping of x's, I pull that out as 1, but then I still have a remainder of x, so he stays inside the radical. So this is my simplified expression of this. Okay? All right. What about some bigger numbers here? So 216. So remember, very first thing, we need to look for the biggest perfect square. So I'm going to think, all right, 1 times 216. Okay? 2 times what? So I'm going to say 216 divided by 2 is 108. Okay? Can I divide 216 by 3? Sure can. 3 times 72. What about 4? 216 divided by 4. 4 times 54. 5 doesn't work. Does 6 work? 216 divided by 6. 6 times 36. Interesting. I'm going to stop there because I just wrote a 36. If we look back here, 36 is on my list, isn't it? So I'm going to use 36 because it's in my list and it's the biggest factor. So I'm going to go back here. I'm going to say, okay, we can write 216. That's the same thing as doing 36 times 6. So now I'm going to spread that out into 2. Square root of 36 times the square root of 6. Well, the square root of 36 is 6, and I'm left with the square root of 6. I can't go any further, and I'm done. Okay. All right. Let's keep going. This one looks weird because there's a number in front. There's that 2. But I'm going to do it in the same way. I'm going to think, okay, how else can I write 63? I could do 1 times 63. I could do 3 times 21. What you can do is start dividing your number by your perfect squares. So I'm going to say, okay, 63 divided by 4. That doesn't work if you're following along. 63 divided by 9. Ooh, that does work. So I can use 9 times 7 because 9 is a perfect square. So I'm going to look at those individually. I'm going to say this is really 2 times the square root of 9 times the square root of 7. I'm going to look at each of those individually. Well, the square root of 9 is 3. And I bring down the 2 and I multiply those together because really those are multiplied together. And I still have my square root of 7. 2 times 3 is 6. So I'm left with 6 times the square root of 7. That is the simplified form. Okay, we're going to do one more together, and then I'm going to let you practice. So we have this square root here. So I have a variable and a number. Whenever we're doing this square roots, we're really think of these as individual problems. Okay, so I can split them apart. Well, the square root of the square root of 25 is 5, and the square root of v squared is v. Because remember, if we have the square root of v times v, that's a grouping, so one v pulls out. Okay, so I pulled out a v. There's nothing left. This is my answer. Pretty cool. Okay. All right, so what I want you to do, oh no, I guess before, I want to mention one other thing. We talked about square roots, but can we simplify other roots? This is called a cube root. So this is called cube root of 8, right? Well, we could think about it in the same way. We have one number that can be multiplied 3 times to get 8. It's 2. 2 times 2 times 2. I have a grouping of 3 And now we're looking at 3. So 1, 2 comes out, and I'm done. Now we're not going to do very many of these. I'm just showing you that it's possible to do other roots. We could do the 4th root. We could do the 5th root, okay? In this class, we're gonna focus mostly on the square roots. But let's do one more. This will help you see it. If I take the cube root of y to the 5th, what that's really doing is multiplying y by itself 5 times. Well, I have a grouping of 3 there, right? So I'm going to pull that out as 1 in front of the box. And what's left in the box? Y squared. So this is my answer. Pretty cool. All right. So now, like I said that I was going to do, I want you all to practice. So I want you to pause your video, work on these problems. I'll leave it like this so you can see all 5. Pause your video, and when you're done, unpause your video and we're going to check your answers. Okay, let's check your answers with mine. I'll scroll down a little bit. I didn't place that very well, did I? Okay, so we'll talk about them three by the other 2. And I'm just going to go over these really quickly since I can't ask you which ones do you want to go over. So if we look for the biggest perfect square of 96. Okay, so you take your 96 and you say 96 divided by 9. That doesn't work. 96 divided by 36. That doesn't work. 96 divided by 16. Sure. So I'm going to do 16 times 6. So really I'm saying the square root of 16 times the square root of 6. The square root of 16 is 4. So that becomes 4. And I'm left with the square root of 6. So there's my answer. Okay. All right, let's do another one. I have the square root of 18. So this can be written as, maybe you see this one more easily, 9 times 2. So I can split this up as the square root of 9 times the square root of 2. The square root of 9 is 3, and I'm left with the square root of 2. Done. Okay. This one has a number in front. So let's first talk about the inside here. Now I see 125. I'm going to try 25 because that seems like maybe 25 will be going into it. And it sure does. I can do 25 times 5 to get 125. So again, I'm going to split these up into 2 problems. The square root of 25 is 5, and I'm left with the square root of 5. 9 times 5 is 45, and there is my answer. Okay. All right, let's do 2 more. All right, we've got a number and a variable, so I'm going to look at this now and say, how can I'm going to split this up into 80 and p to the 3rd. So now let's look at just the 80. Well, I could do 10 times 8, but that doesn't really work, right? All right, let's look at a different number. Let's do 80 divided by 16. Wow, that works. Let's do 16 times 5. And if I look here, that's p times p times p. Okay. The square root of 16 is going to be by itself. Okay, and remember that this is all multiplied together. On these p's, I have a grouping of 2, so I'm going to pull that p out by itself, and I'm left with the square root of p. Okay. The square root of 16 is 4 times the square root of 5 times p, the square root of p. Now, here's the cool thing about this. When I have radicals and I'm multiplying, I can multiply the outside numbers and I can multiply the inside numbers. So what this becomes, I'm going to multiply the 4 times the p and get 4p. Then I'm going to multiply the 5 by the p, and I have the square root sign, and then I have 5p underneath. That's my big ol' answer. I know that one was hard. Okay. All right, one more. Let's focus on the number. I'm going to split all of these up. So we have 75 times the square root of x squared y. I'm going to keep all the variables together. When I look at 75, I think of quarters, right? 3/4. So I could do 25 times 3. I'm going to write out all of my variables, x, and y. The square root of 25 is 5. And when I look at this grouping, I have a grouping of 2. So I'm going to take out an x, and I'm left with the square root of y. So I'm going to multiply these together. I'm going to multiply the 5 times the x, right? The 5, I said the 5 times the x to get 5x. My square root sign, I meant to change the color, but that's okay. And then 3 times y. There's my beautiful answer. Okay. If you have questions on these, you can always rewind and watch again, or drop me a note on the side. So, very good job today. A few reminders, right? Tomorrow's Wednesday. We're going to have our normal asynchronous time, just like we do every Wednesday. You will have a quiz tomorrow. So when you log on tomorrow and you go into the Wednesdays, where the Wednesday spot usually is, right? You're going to find a quiz. It's not going to cover radicals that we did today, but it will cover absolute value, piecewise functions, properties of exponents. I think that's probably it. Okay. We're going to continue working with radicals on Thursday and kind of reviewing everything that you learned in these past few days. Okay, so on Thursday, we'll be back with our live sessions, so you don't have to miss me too much. Okay, so I hope you enjoy your day. Again, always reach out to me if you need help or if you have questions, and I hope today's lessons made sense. All right, very good job, y'all. See ya.